Hello there, welcome back. We're going to talk about quadratics again. This time some applications and modeling, which is a little bit the same thing. Before we start, of course, got the pen rolling here. Check it out. And check it out with the actual pen. And I think we're good. Let's roll. All right, we've got an example here of a problem and we want to solve it. We have rectangular sheets of metal. So the first thing you want to do probably is draw a bit of a picture. Now it says the length is 3 times the width, so why not say the width will be x. That means x here. It says the length is 3 times that, so put 3x there. Now what we're going to do is we're going to draw another picture here. It says what we're going to do is we're going to cut on each of the corners so we can fold it up and make it into a box. Now it says we're going to cut squares in each of the corners, sort of like this. We'll make this exaggerated so we can see it. So we're going to cut that out and cut this out, and here and here. Once we cut those out, we're going to lift these sides here, 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 and here to make a box. Now, the specifications say that the volume of the box is supposed to be 1,435 cubic inches. You want to find the dimensions of the original piece of metal. So that's good. We started with x over here on the original, and we're going to make the box. And the box, once we cut these out and fold these up, the box, and excuse my drawing, but the box might look something like, something like this. Okay, something like that. Now go back here and take a look at this. This is going to be one of the sides of the box. So this side right here is going to correspond to one of the sides. This is going to correspond to another side. And this part right here is going to be the height of the box. So here's our box to begin with. And these corners are going to be 5 centimeters on a side. I'm just going to mark one. We don't need it on all of them. So what does this look like? Well, after we cut out this side, well, let's look over here. This side is x to begin with. We're going to cut out 5 centimeters here, another 5 centimeters here. What's left? What we'll have here is x minus 10, because 5 centimeters are taken off each side. Now this is going to be the top, so this will be x minus 10 here. Now what about the other side? Well, this side began as 3x. We're cutting 5 centimeters here, 5 centimeters here, so a 3x minus 10 for that side. So what do we have all together? We've got x minus 10 on one, we've got 3x minus 10 on the other side, and we've got 5 centimeters high. And what we want to end up with is a volume of the box, which is 1,435 cubic inches. One thing we need in addition is how do you find the volume of a rectangular box? Well, it's length times width times height. And we've got the length. So where can I put this? I guess we'll squeeze it in here. The volume, that's 1435. So we're taking this equation and putting in what we know. 1435, that's the volume. The length is going to be 3x minus 10. The width is going to be x minus 10. And the height is going to be 5. And there we've got our formula. So keep that in mind. 1435, 3x minus 10, x minus 10, and 5. So we read the problem. We found the dimensions of the original one. Find the dimensions of the other one. There's our box. 5 for the height. Where am I? There we go. 5 for the height. The width is x minus 10. And the length is 3x minus 10. So 1435 equals 3x minus 10 times x minus 10 times 5. And that will be our box once those corners are cut out and we put these sides into the right position. So here's the formula. You need the formula. Length times width times height. 1435. Put all those pieces in. You got the formula. Now, one thing that you can take out of this formula right away is that the length and the width, remember we've got a box. Let's see if I can draw a better one this time. Here's the front side of the box. And it goes back and back that way. Now the 3x minus 10, which is here, well, you know length and width and height can't be negative. It has to be positive. So right away, you know 3x minus 10, the length has to be greater than 0. Can't be 0. It has to be positive. So that means 3x is greater than 10. X is greater than 3 1/3. By the same token, oops, wrong place. This is x minus 10, and that can't be 0 either. It has to be positive. So that means x minus 10 has to be greater than 0, which means x is greater than 0. And both of those have to be true. This and this. Now we know this is 5, so we don't have to worry about that. So take a look at those two. Oops, I'm missing a 1 there. There we go. So we've got these two conditions, and they have to be both true at the same time. So x has to be greater than 3 1/3, and x has to be greater than 10. Well, if you think of those on the number line, that means, in essence, that x has to be greater than 10. So, let's get to the equation. And there's our equation with the right side multiplied out. Next, we'll subtract the 1435 from both sides. Why? Because we need the 0 on one side of the quadratic equation so we can solve it. Whether we use factoring or whether we use the quadratic formula, it doesn't matter. We have to start with 0 on one side. Now, first thing we can do is we can divide. Notice all those have 5, 0, and 5, so you can divide 5 into all those. Plus you're dividing 5 into the 0, but you get 0 equals, and you got this expression right here. You can factor it very carefully, of course. If you have trouble with that factoring, of course, there's always the quadratic formula, but factoring will go faster if you can do that. Because you know, looking at the 3x squared, that it'll have to be 3x and it'll have to be x if it can be factored. And because there's a minus here, that means one of these is going to be a plus and one of these is going to be a minus. It might be the opposite. So be prepared when you find the numbers that go in here and here, you might have to swap the plus and the minus. So here's the factorization. Now the zero factor property says once you have this, then either the first factor is equal to 0 or the second factor is equal to 0. Well, this first one says 3x is equal to 11 thirds. Oops, is equal to negative 11, sorry. Or x is equal to negative 11 thirds. Well, what does x represent? That represents the side of the original piece. That's impossible. You can't have a negative there, so scratch that. Go over here. Let's see what we get. Add 17 to both sides. X equals 17. Now that looks like a good answer. 17 inches. Now we can go back. What does the original rectangle look like? The original rectangle, if we could go back a couple slides, one side is x, one side is 3x. So the original box, draw that again, one side is 17 inches and the other one is 3 times that, or 51 inches. And those are our answers. So we solve the equation as we just did. And we throw this out because we can't have a negative for x. And we state the answer. Notice that the answer is in words because the original problem was in words. So keep that in mind. Also keep in mind that it's 17 inches by 51 inches. Do not leave out the inches. I'm very picky about that and very honest about that pickiness. So number 6, check it out. What do you have? 51 minus 10, 41 is the bottom of the box, and so on. You can read the rest. So what's the volume of the box? Length times width times height, 41 times 7 times 5, and you've got your 1435 as required in the specifications. Good? All right, let's move on. We've done one example. Let's take a look at a second one that has to do with a right triangle. Lots of things have right triangles, just like our box did, even though my picture might not have looked perfect. But you do have right triangles. That's why it's called a rectangular box. Now, according to the Pythagorean Theorem, if you take each of the sides, square them, add that together, it's going to equal the square of the hypotenuse. So all you have to do is identify the sides, identify the hypotenuse, and use the Pythagorean Theorem. It's used very often, so you might want to put that in your notes, your special notes that you're going to carry around. So this is what you've got, and this is what you're going to remember. Remember, the two that you are going to be adding the squares for are the legs, and this is going to be the hypotenuse. I'll shorten that. Remember, all three of them are squared. Now here's our problem. We have a piece of property the shape of right triangles. So right away, there's our property. Here's our right angle. Now it says the longer leg is 20 meters longer than twice the length of the shorter one. So we'll start with the shorter one. We'll call it x, and that'll be x meters. Now how long is the other one? It's 20 centimeters longer than what? Than twice the other leg. And the hypotenuse is 10 meters longer than the length of the longer leg. So the hypotenuse is 10 meters longer than the length of the longer leg. And the longer leg was 2x plus 20. There's the hypotenuse. Now, you might want to hit pause, read through that, and see how these all go together. Before you do, though, you might want to take this hypotenuse and simplify it. 2x plus 30 will be the expression for the hypotenuse. So we'll put that in here. Make that a 2. Okay. Now, where are the legs? The legs make up the right angle. So these are the two legs. You're going to square each of those, and you're going to square the hypotenuse. So first leg squared plus the second leg squared equals the third leg squared. And then a little bit of algebra, of course. So you read the problem. You've got the lengths of the three sides. You assign a variable. X is what you're going to use, and you're going to assign a representation for the other leg and for the length of the hypotenuse. Those are your three. And there you got a picture. A little bit better than the one I had. Now write the equation using a squared plus b squared equals c squared. And put our expressions in there. Be careful about squaring the 2x plus 20 and the 2x plus 30. Just as an example, the 2x plus 20. If you're going to square that binomial, and I'm going to do it the short method. Now you can write it 2x plus 20 times 2x plus 20. That's the long way around. If you remember the shortcut, we're squaring a binomial. Well, first of all, you squared the 2x. That'll be 4x squared. Square the 20. That's 400. What's the middle term? The middle term you get by multiplying the two terms and doubling that answer. 2x times 20 is 40x. Double that, you have 40x. And that will get you this part. Do a similar thing for the hypotenuse. So there are the three terms squared, and then go ahead and solve that equation. Getting everything on one side, because we have to have that 0, put it in standard form. Factor it if possible. If in any question like that, if you have trouble factoring it, you try for like 5 minutes and you're not getting anywhere, use the quadratic formula. It's longer, but it's a sure thing. So we've got these. Now remember, the zero factor property says one of these two, this or this, has to be 0 if we end up with 0. So x minus 50 equals 0, or the x plus 10 equals 0. Now, do you see the handwriting on the wall? If you look at this one would say x equals negative 10. Remember, we're talking about a triangle. This side was x. Can it be negative 10? Of course not. So we're going to scratch that out. Hopefully we get an answer here. And we do have one. X equals 50. Now, what do we have? That means we've got 50 here. Remember, this side was 2x minus 20. So we'll have 2 times 50 is 100. Oops, that's plus 20. So this side is 120, and this side is 3x, 2x plus 30. That gives us 130. Now double check. We think we've got 50 and 120 and 130. So let's check. 50 squared plus 120 squared, is that equal to 130 squared? One way you can do this is you can square this. That would be 16920, 16,900. And then add these two together. 50 squared is 2,500, and 120 squared is 144 with 2 zeros, or 14,400. Add those two together, and sure enough, you got 16,900. So that 50 for this is right, the 120 is right, and the 130 is right. Next, we're going to talk about the height of a projected object. And since we're on the Earth, we can use this equation right here. Why am I talking about being on the Earth? Well, this negative 16 that you see right here is a result of the fact that we're on the Earth. If we were on the Moon, or on Mercury, or on Jupiter, this number would be different. And the reason it's negative here is because gravity pulls us downward. And that means a negative distance. So this represents distance. T represents how long that object has been in the air. Same thing for this T. This V sub 0 means how fast was the object going upward when it was released. And S sub 0 means where was the object? Was the object at ground level, which means that was 0, or was the object maybe 50 feet above the ground, in which case this would be a 50 instead. Where is it initially? The 0 means when everything started, what did we have? What was the distance? What was the speed? And of course, we know that we're on the planet Earth, so the negative 16 works for this one. So here's our formula, one we're going to use. And it says the projectile is launched vertically upward from the ground. The initial velocity is 100. So this number right here is 100 feet per second. It's sent from the ground, and the ground is at 0. So we actually have a plus 0 here because it starts at 0 feet above the ground. And we want to know something about the distance at any particular time. So when will it be 50 feet above the ground? Well, that means S, the final location. We could also put this as S sub F, because it'd be the final distance above the ground. Well, in this case, it'd be 50, and that's equal to negative 16t squared plus, let me check here, 100, yes, plus 100t. And we have a quadratic because we've got that t squared. So there we've got the equation. We'll simplify a little bit. We need that 0 because we've got a quadratic regardless of which way we solve it. We can reduce it a bit by dividing everything by 2. How many seconds will be 50 feet above the ground? Well, let's see. we can put it into the quadratic formula. And all we need to do is be very careful in evaluating this. Notice, for one thing, you've got a minus and a minus here. So this will give you a positive 50 in front. You've got the plus or minus, so we're going to get two answers. You're going to be squaring the negative 50, so this will be a positive 2500. And writing this out enables you to take a look at the 4, the 8, and the 25 and see that you've got a negative and two positives you're multiplying together. So this part will also be a negative. And just put the rest in your calculator perhaps, or solve it by evaluating each part individually. You've got 1700 inside the square root, and you definitely need a calculator for that. You actually get two results. Isn't that interesting? Well, remember, what we had is we had something on the ground, and it was shot into the air. And of course, eventually, it's going to come up to the top, and it's going to start falling down again. What we want to know is when it will be 50 feet above the ground. Well, let's say this is 50 feet. That means that it's going to be hitting 50 feet two different times, on the way up and on the way down. So after 0.55 seconds, it's going to be 50 feet above the ground. After 5.7 seconds, it's going to be 50 feet above the ground again. Now, another question you might be asked is, how long is it going to take for it to return to the ground? Return to the ground means that final distance, this if you like, will be 0. So we'll have 0 equals negative 16t squared plus 100t. And we can solve pretty easily, actually, because we can factor this without too much trouble. Factor that negative 4t out. Remember, we've got two factors here. We've got this number, and we've got this number, and the product is 0. So one of those has to be 0. So negative 4t equals 0, or 4t minus 25 equals 0. Well, this one's pretty easy. T equals 0. That makes sense because it started out on the ground. And 4t equals 25. T equals 25 over 4, which is 6 1/4 seconds. And this is at 0 seconds, our two answers. So the solution will be, we've got two different times. Next one, the I-Ride trolley service carries passengers along an end in Orlando, Florida. So the bar graph shows the actual readership. This is actual over here. These are the actual figures. And we're mostly interested in the ridership, which would be on the vertical axis. That'll be the Y, the ridership. Where am I? There we go. Y is the ridership, and X down here represents years, and it says down here it's the years from 2000 to 2018, so we're going to let X equals 0 represent the year 2000, 2001 will be represented by X equals 1, and so on. So we'll use that model and determine the ridership in 2018. And we've got our formula back here. If we wanted in 2018, that means since X represents how many years since 2000, we're going to put 18 in where the X's are. A simple job for the calculator. Remember the shortcut that I told you earlier? Take the 18 in your calculator, store into the X, and then all you have to do is put this expression in your calculator. It will use the 18 for the X's, and you get your answer. So the actual ridership was 1.3 million. If we put the 18 in, what do we get? There's the 18 in, and I've made a small mistake here. That's supposed to be squared, right? But you would have gotten that correct. And you get about 1.4 million, which isn't too far off. It's a little bit over the 1.3, which was the actual. This part is from the model. Models aren't always perfect, but usually if we get a good model, it's close. But it's a little bit over by 100,000. It depends what you consider as too far over or too far under. Second part of the question is, when do we expect it to hit 1.8 million? So you take your original formula and you say, when is that 1.8 million? So put the 1.8, and there's your formula. And we've got a quadratic equation. No big surprise. And notice you've got decimal fractions here. You're not going to factor that. No way. Unless you're a real wizard. So make sure you get a 0 over here by subtracting 1.8 from both sides. Use the quadratic formula. So there's your 0. You're ready to go with A, B, and C. There it is. Ugly as it is right now, in your calculator. Do this once with a plus, and the second time using a minus there. And you'll get your two answers, 2.0 or 14.0. So what year did the ridership hit 1.8 million? Well, the year 2000, where am I? The year 2000 is what corresponds to the x equals 2 that we got for our solution. 2014 is what corresponds to the 14 that we got. And there are your two answers. Well, that was a little bit of how to use a quadratic formula and how to work quadratic type equations in models. I'll see you next time when we're going to do something a little bit different. In the meantime, work on some of those exercises, write down the questions that you need to ask, and bring them to class. I'll see you then. Goodbye.